welcome to video lecture on variation of parameters. This is my second video lecture on variation of parameters. Yesterday we discussed the proof of variation of parameters. That is, if some differential equation given of second order in the prescribed format, that is in the format d square y by dx square plus p dy by dx plus qy is equal to r, then how to find the solution of these type of differential equations. Okay, first of all, stay home, stay safe, don't go anywhere. Okay, and all the video lecture will be provided you on the YouTube, and notes will be provided you by sharing in the WhatsApp. Okay, after the completion of the unit I will share the notes. Okay, today we discuss the problems related to variation of parameters. Yesterday what we did, once again I am recalling. Yesterday, see here, the differential equation of this type, d square y by dx square plus p dy by dx plus qy is equal to r. If it is the differential equation of this type, then first we found the complementary function, that is yc, c1 u power of x plus c2 v of x, not u power of x, this is u of x. If it is the complementary function, then what we assumed yp as, here it is a into u plus b into v. We assumed yp, particular integral, it is in the form. Later what we found, yesterday also we derived the formula. Here it is, yeah, here a is equal to minus integration v into r of x divided by u into dy by dx minus v into du by dx dx, and the b value integration u r of x u dv by dx minus v du by dx into dx. These are a and b values. So at last we can write the general solution as y is equal to yc plus yp, where yc is c1 u of x plus c2 v of x plus a into, this is yp, a into u of x plus b into v of x, this is yp. Okay, instead of writing here u dv by dx minus v du by dx, just we write, that is w u of v, that is u dv by dx minus v du by dx. This is always not equal to 0. Okay, Wronskian never zeros. If it is 0, u and v will be linear dependent solutions. But here in differential equation, solutions are linear independent. Okay. Now we go to the first problem. Generally, the problem, in the examination, they ask the method, they specify the method also. In which method you want to do, that is here, see, like this. Solve d square minus 3d plus 2 into y is equal to sine e power minus x by variation of parameters. Here they have specified variation of parameters. Okay. And in some, why I am saying the specification means, some problems may do in 2 to 3 methods. So then you may get confused in which method you have to solve this one. Okay, in variation of parameters, generally they specify the method. Okay, now what we have to do? Recall the variation of parameters method. First we have to find the solution for homogeneous differential equation, that is d square minus 3d plus 2 is equal to 0. If it is not r of x is there, assume if it is 0, then how to find the solution. In the initial chapters you know how to find the yc. Okay, so first what we have done, auxiliary equation, that is instead of d I am writing m. Okay, m square minus 3m plus 2. Just instead of d, I have written m. Then how to find the m values here? Okay, by factor method, here 2 into m will be 2m square. That means how to write minus 3m as sum of, how write minus 3m as two values, which product is 2m square and sum is minus 3. So what I got, m square minus 2m minus m plus 2 is equal to 0. In first two terms, have taken m outside. That is m minus 2. Here also how to get m minus 2. For that purpose, I am taking minus 1. So you get m minus 2 is equal to 0. Okay. Again, here m minus 2, m minus 2. If I take outside, then m minus 1 is equal to 0. So I got two product of two values, that is m minus 2 is equal to 0, m minus 1 is equal to 0. So here m minus 2 means m is equal to 2, m minus 1 means m is equal to 1. So here I got two values, one is m, one is 1, one is 2. Both are real and distinct. So if the two values, we got two values which are real and distinct, then the complementary solution to the complementary function will be yc is equal to c1 e power x plus c2 e power 2x. Okay, this is our yc. Now we write the yp, that means particular integral, by using the yp value. That is, here I am assuming u is equal to e power x, v is equal to e power 2x. And one important thing is, don't get confused which one we have to assume as u and which one we have to assume as v. It's a random choice. It doesn't affect the final. Even though here I am assuming u is equal to e power x, even though if you assume u is equal to e power 2x, you get the same answer. Okay, so yp will be a into u of x plus b into b of x. Now our aim is to find a and b values. Okay, so we have the formula we derived in the last class. A is equal to minus integration v into r of x dx by u dv by dx, u dv by dx minus v du by dx. Okay, this value, the denominator value, again we use in the b value, finding b value also. So here I am finding separately u dv by dx minus v du. Here we write it as Wronskian also. Okay, we assume we name it as Wronskian also. In next problem we have done like that. So what is u and v values? Once again recalling here, u is e power x, v is e power 2x. So yeah, let's go to here. U is e power x, dv by dx is 2 into e power 2x minus v is e power 2x, du by dx is e power x. E power x differentiation is e power x. Here 2 into e power 3x minus e power 3x, that is e power 3x. That is Wronskian of u comma v. Here we haven't written that one, but that is Wronskian of u comma v. So what we are going to do? Now we find the a value, all the value we have which are required for a. See here, v into r of x, u dv by dx minus v du by dx. V value already we have e power 2x. R of x in the problem it has given sin e power minus x. This total value, denominator value, e power 3x dx. Okay, so yeah, this is minus e power 2x by e power 3x will be e power minus x, and sin e power minus x as it is dx. Now without getting confused, we are assuming t is equal to e power minus x. Then what will be the dt? Dt will be minus of e power minus x dx. Okay, return to the problem. A is equal to integration see here, dt is equal to minus e power minus x dx. So minus e power minus x dx. Instead of these three values, I am writing dt. And sin e power minus x will be sin t. So this is integration sin t dt. What is the integration sin t value? It becomes minus cos t. And replacing t value, minus cos of e power minus. Here, no need to write plus c. Why? Because here we are finding the a values, not it's not related to uniqueness. Okay. Next, let's go to b value. B, u into r of x by u dv by dx minus v du by dx dx is equal. What is our u? E power x, r of x sin e power minus x. This value already we found when we are solving the a value, that is e power 3x. If I shift e power 3x to the numerator, it becomes e power minus 3x, and e power x, e power minus 3x becomes e power minus 2x sin e power minus x dx. Here, see here, e power minus 2x, I am writing e power minus x into e power minus x for our convenience. Okay. So here, let t is equal to e power minus x, then dt becomes minus e power minus x dx. So minus dt is equal to e power minus x dx. So here one e power x we are taking for dt and another for t. Sorry. So it becomes, so 1 e power minus x I am taking t, sin e power minus x sin t. Another e power minus x into dx I am taking minus dt. Okay. So then it becomes integration of t into sin t. By applying the integration by parts directly, I am applying integration by parts formula directly here. So t into sin t integration is minus cos minus t differentiation is 1 minus cos t differentiation is minus sin t. Okay, it becomes minus into minus plus t cos t minus into minus plus again 1 minus minus sin t. By replace t value with e power minus x, e power minus x cos e power minus x minus sin e power minus. Here I said integration by parts formula. Here suppose any two functions are there, f into g. Here which function we have to assume as f means for which function derivative will be 0 1 or 2 times. Here in this problem we assumed f as t. Why? Because differentiation of t is 1 and again differentiation of 1 becomes 0. So for that part, so f g1, here g1 means integration, f dash means differentiation. So the formula will be like this: integration f into g, f g1 minus f dash g double 1 means double integration of g. That is r1 in another way you can say integration of g1. Okay, plus alternate plus minus plus f dash into differentiation f double dash g3 ones minus so on. Okay, here we assume f as t, g as sin t. Sin t, just let me check sin t. Okay, so we got the b value also. Then y is equal to yc plus yp. Yc we have substituted here, c1 e power x, c2 e power 2x plus yp, that is a into ux plus b into bx. We can simplify also. See here, if you simplify, here one term will cancel, minus cos e power minus x, e power minus x, here plus e power minus x cos of e power. So these terms gets cancelled. Finally, we got e power minus 2x sin e power minus. Okay, I hope you understand the problem. And here nothing is there. First we have to find the yc. Write in c1 into u of x plus c2 into v of x. Then assume yp as a into u of x plus b into v of x. Then apply the a formula, b formula, then the problem is solved. Okay, and one more problem we'll do. See here, the problem is d square plus 4d plus 4 into y is equal to 3x e power minus 6. Now you might be got one idea why we are using variation of parameters. So far you learned so many methods. Q is equal to e power ax, Q is equal to sin ax, sin bx, like that. But product of two terms, it's a little bit hard in those type of problems, and sometimes it may not be able to find the solution like the previous problem. Sin e power minus x, we can't apply any of the formulas, any of the methods you learned before. So by the variation of parameters we can solve all those. Okay, see, first what we have to find, we have to find the auxiliary equation, that is m square plus 4m plus 4 is equal to 0. This is m plus 2 whole square, and yc, here why I am writing here means here 2 value repeating 2 times. That's right, minus 2 value, m plus 2 whole square means m is equal to minus 2 and real and repeating. So the yc will be c1 plus xc2 e power minus 2x. But we should not write like this directly. Why? Because we need u value, v value separately. So yc will be c1 e power minus 2x, c2 x e power minus 2x. Okay? So here u value e power minus 2x, v value x into e power minus 2x. Of course, these two are linear independent. So yp will be a into u of x plus b into v of x. Now here direct first we are finding u dv by dx minus v du by dx. Why? Because this value we use in a and b to find a value and b value. So u e power minus 2x dv by dx. Actually dv by dx is x into e power 2x. This is product of two functions. So we applied the formula. X differentiation is 1, e power minus 2x as it is. Here x as it is, e power minus 2x differentiation minus 2 e power minus 2x minus v x e power minus 2x differentiation of e power minus 2x minus 2 e power minus 2x. Okay, if you simplify you will get the e power minus 4x. So let's move to find the a value. A minus vr by u dv by dx minus v du by dx is equal to minus v is, what is our v value? X into e power minus 2x. R of x is 3x e power minus x. That is given in the problem. This value just now we found, that is e power minus 4x. So if I simplify, here e power minus 2x, e power minus x, e power minus 3x, in denominator e power minus 4x. It becomes e power plus 4x when it comes to numerator, and it becomes e power x. Here x square, and I am taking minus 3 outside. See, it is x square e power x. Just now we written integration fg formula. In the previous problem we have specified this one. Okay, but see here, which one we have to assume as f means x square. Why? Because x square differentiation is 2x, 2x differentiation is 2, 2 differentiation is 0. Okay, so x square integration of e power x is e power x minus differentiation of x square is 2x. Again double integration of e power x, same, plus here again if you do one more time differentiation, here 2x differentiation is 2 e power x. Okay. And next time we are not writing next time. Why? Because differentiation of 2 is 0. So this is the a value. Okay. Next, b value, here b is equal to u r of x by u dv by dx minus v du by dx, and u is equal to e power minus 2x or 3x e power minus x e power minus 4x. Here numerator e power minus 3x, denominator e power minus 4x. It becomes e power 4x. When it comes to the numerator, it becomes x into e power. Same again, integration fg formula what we used in the previous problem. It becomes x into e power x minus x differentiation is 1, e power x as it is. So at last we can write y is equal to yc plus yp. So c1 e power minus 2x, c2 x e power minus 2x. This is a value, minus 3 into so on u of x plus b into v of x. Okay, if you simplify, you will you may cancel the sum terms also, then you will get the final value. Okay, in this class we discussed two problems in variation of parameters. In tomorrow's class also again we discuss the two more problems in variation of parameters and end this topic of variation of parameters. Okay, that's all for today. And one more important, stay home, stay safe, don't go outside. Your online classes will be provided to you by the YouTube. Okay.